Well, hello everyone, and welcome to the May 2023 edition of the St. Louis Java Users Group. For those who don't know, the St. Louis Java Users Group is an informal group. Attendance is free. There is no formal membership list. Our normal meeting date is the second Thursday of every month except December, when there is no meeting. There's just too many things going on over the holidays for us to organize a meeting in December. When we meet in person, you can join us for food and social at 6 p.m. and the presentation and meeting starts at 6:30 p.m. When we meet in person, our normal meeting location is the Object Computing Incorporated Training Room, and that's located at 12,140 Woodcrest Executive Drive. That's Suite 310, and it's in St. Louis, Missouri. I'd like to introduce the other members of the St. Louis Java Users Group. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Allspaw, that's me in the middle, Wei-Chi Gao, and Kathy Zwang. You can reach all of us at the St. Louis Java Users Group Steering Committee by sending an email to that address that's at the bottom of your screen there. That's javasigsc@ociweb.com, and we'll all get your email. I'd like to welcome our newest steering committee member, and that's Robert Levitt. The St. Louis Java Users Group would not be possible without the support of our sponsors. So I've got the logos up there for various sponsors that we've had over the years. So from left to right, top to bottom, we have Object Computing Incorporated. They are the original founding sponsor going back to 1997 when the St. Louis Java Users Group was originally formed. JFrog has also been a fantastic sponsor. They cover the fees for us to have a Zoom account, and they also cover the fees for the meetup page. It's free for you to go to the meetup page and sign up and attend a meeting, but it does cost the jug some money to be able to have a page up on the meetup.com website, and they cover the cost for that. And they occasionally will come on and raffle some prizes as well. Signature Consultants and Adaptive Solutions Group are both headhunters. So if you are looking for a Java position, or really any type of developer position, or if you have a developer position that you would like to fill, just do a quick Google search and let them know that you heard about them through the St. Louis Java Users Group, and I'm sure they'd be happy. When we meet in person, they sponsor the food, but we haven't figured out a way to do that remotely. At the end of the meeting, we will be raffling 2 JetBrains licenses. Now, if you're watching the recording, I'm sorry you're too late. You must be present to win one of the 2 JetBrains licenses that we will raffle at the end of the meeting. So thank you to JetBrains for sponsoring those JetBrains licenses. Elastic is a search engine company. They also sponsor some gift cards that we have raffled in the past. Intertech is a training company, and if you look them up, they have lots of online training videos. So if you're looking to expand your skills, look up Intertech, and they're a great sponsor as well. And they sponsor the famous Screaming Flying Monkeys. They're little dolls that if you throw them up against the wall, they scream, and they're a lot of fun. Also coffee cups and mouse pads as well. Manning will be sponsoring 2 Manning ebooks that will be raffled at the end of this at the end of the meeting. But again, you must be present to win if you want to participate in the raffle for the Manning ebooks. Pearson has also sponsored physical books as well for the St. Louis Java Users Group. So thank you to all of the sponsors for the St. Louis Java Users Group. I do have a few announcements. The Kansas City Developer Conference, that's KCDC, will be June 21st through the 23rd. And if you'd like more information about it, the website is kcdc.info. They're organized by the Kansas City Java Users Group. And so thank you for being kind of our sister Java Users Group. So I just thought I'd put a shout out for the conference that they sponsor every year. Strange Loop 2023 will be coming up in September, so it's not too early to mention that. And you can find out more about that if you visit their website at thestrangeloop.com. Now, if you want to keep up with the presentation schedule, all you have to do is just check the Meetup site. That's meetup.com/gatewayjog. And as we schedule presentations, they get posted to that Meetup group, and any changes in location or anything like that will be posted there. Now, if you're interested in giving a presentation or becoming a sponsor of the JUG or serving on the steering committee, then the thing to do is to email the steering committee at that address that I mentioned before. Again, that's javasigsc@ociweb.com. So tonight we have a presentation by Scott Wierschem called Making Sense of Other People's Code. So that's all of my announcements. What I'm going to do is I'm going to stop sharing my screen, and then that should allow Scott to share his screen. So why don't you take it over? And again, if you have any Q&A questions, just go ahead and put those in the chat for Scott. And then at the end of the presentation, we will take care of the raffle. So why don't you take it away here, Scott?
Okay, great. Thank you very much, Bruce. I appreciate it. It's I'm really excited to be speaking to the St. Louis JUG while I live in Houston now. I was born in St. Louis, so go Cards. My talk is about making sense of other people's code, because we never have trouble making sense of our own code. So let's look at some of the things we might consider when we're looking at other people's code. Now, this here is pretty much my guiding principle. I heard a speaker say once that our lives change when our habits change. So effectively, my goal here in today's presentation is to help you to learn some new habits and ways of thinking about things that can have a positive impact on your career and help you become a better developer. Okay, so anyway, 2004, Steve McConnell wrote in his book, Code Complete, he talked about a study from back in 1964 that measured how programmers spent their time in any given work week. And among the various things that they did, they spent 14% of their time reading source code and 13% of their time writing source code. And his comment was that he has seen nothing to indicate that those numbers have changed significantly over the years. Now, a couple years later, Uncle Bob wrote his clean code book, and he claims that developers spend 90% of their time reading code. He didn't reference any studies, but he's a pretty smart guy. So frankly, I'll let him and Steve duke it out. However, in 2017, IEEE published a study claiming that nearly 60% of developer time is spent trying to understand programs as opposed to trying to create new programs. Regardless, at least discusses how to read your code. So if we spend half of our time doing this, we probably ought to know how to do it well and how to develop our skills so that we can do it better. All right, and that's what we're talking about today. All right, so first off, my first question: what is it that you need? Why do you read code, and what would you be looking for? Is there a specific problem that you have in reading code? What makes it difficult for you? Where would you get stuck? I want to make sure that I make this useful for you. So if you have any specific questions or concerns, we can I want to make sure I address them. So just put it in the chat if you have any questions or comments that you want to make sure that I get to. Okay. Now let's consider the difference between reading a book versus reading some software. When you have a nice book, it's effectively a passive exercise. You sit down in a comfy chair with a glass of wine and flip through a nice book. You can remember the characters and the relationships, but unless you're like reading a mystery novel or a technical journal, you really don't have to pay particularly close attention. If you're reading code, though, you probably have to have a pen and paper nearby to take notes and maybe even have a printout to scribble on. You're going to use different tools and techniques, and frankly, it's hard work. It's a very different kind of exercise. So what makes code hard to read? I see I've already got a couple of comments that no comments in the code, or I wrote it 5 years ago, and what the heck was I thinking? Someone else wrote it. That's sort of the main thing that makes it hard to read. I wrote it, but I must have been drunk at the time. No documentation, so that was one of the things. People don't follow coding standards. Of course, magic numbers and reused variables. Having very large classes and global variables or singletons, which are pretty much the same thing. Generally, bad naming makes things hard. Code that doesn't have any tests. I see Jake's put that in there. Code no longer matches the documentation. What are magic numbers? They are numbers like 16 that appear in the code. And you go, what the heck is a 16? What does that mean? That must mean something. Does that mean the same 16 as the 16 that is in this other module over here? Who knows? It's very frustrating to run into one of those. So if you think about it, this is really a list of code smells. And we want to make sure that we make our code easy to understand, because frankly, it's easier to read if you can understand it. It's easier to, well, I guess code that's easy to read is easier to understand. And if I'm able to understand it, then I'm able to maintain it and cause fewer bugs because I understand the implications of what's going on. The bottom line is we can't write good code unless we can recognize bad code. Gigantic methods, right? That's our large classes and that sort of thing. Okay, so I'll never forget one instructor I had who talked about obsolete code in software. Obsolete code should be kicked to the curb. Yes, code that is never called can be deleted. And one of the great things that we have that will assist us in doing that confidently is called source code control. If you need it, you can always go back and get it. Hard time reading a Kotlin built-in function was overloaded. Oh, yes. Any C++ developers will recognize people who overload odd things like the equals function. Yeah. So why do we read code anyway? We want to learn how something works so that we can either add some feature or fix a bug that's in that. We might want to learn how some new library or framework works. And so we dig into the source code to see how it does things. Or we can see how other people have implemented things so I can learn new techniques for writing my code better. Or probably the second most common reason we're reading code is for a code review. We're looking at someone else's code to make sure that they're not going to be introducing any new bugs. Right, so a reference book for today's discussion, I'll be leaning a lot on this book, The Programmer's Brain by Felina Hermans. In this book, she talks about how our brains work, especially how software developers' brains work, and gives us suggestions on how to use the knowledge of how our brains work to increase our skill set and become better at programming. I personally like to read about how my brain works so I can effectively use this machine between my ears, and I'm really impressed with this book. It's got a bunch of amazing insights and suggestions for using your brain more effectively. I highly recommend it. Okay, so this is a model of our brain. When we learn something, we get information that comes in, we learn it, we are first moving it to our short-term memory. And that's very small. Basically, you can remember between 5 and 9 items at a time in your short-term memory, and then it moves to your working memory. And from there, it's associated with something that already exists in your long-term memory, okay? We'll dig into this a little more deeply and see how it works specifically for us developers. Basically, there's 3 different ways that code can be hard to read, all right? There's basically, we don't understand it. The code has an unfamiliar syntax, so we don't understand it. Here it's quite literally Greek. This is, if you don't recognize it, it's APL. And if you don't know it, if you don't know this is a comment describing what he does, this would be really hard to understand. Another way that code is hard to read is that it's unfamiliar. I don't know the syntax. I may not know how this lambda expression works. I don't know about y'all, but I work with 8 people on my development team, and I don't think any of them is really comfortable or strongly familiar with lambda expressions. So even after all this time, so yeah, I may not just not know how that works and what it does. And finally, there's a lack of processing power. There's a sophisticated algorithm that I have to go through, and I just can't keep all of this crammed into my brain. So so let's look back at our brain diagram here, and we'll use this as a map for how we can overcome the 3 types of confusion. Again, you look at our long-term memory, you can think of that sort of as your hard disk. You can look at your short-term memory, think of that sort of as RAM, and your working memory would be kind of like the CPU, or maybe registers. If you're reading code, you're generally running a program in your head, and it's called tracing. So how does our brain work when we do this tracing? We read the code into our short-term memory, and you consider that your short-term memory lasts about 30 seconds on the outside, okay? You may have heard of Miller's magic number, which is 5 plus or minus 2. And Felina mentions that, I don't know, possibly with the advent of social media and cell phones, that number is more like 4 plus or minus 2. But how do we increase our short-term memory? Because this is sort of the gateway to anything that goes into our brain, all right? So we're going to have a quick exercise. I'm going to show you some characters, and we'll see if you can remember them. I'm just going to show them really quickly, all right? Ready? 3, 2, 1. Okay. So that was probably hard to remember, unless you're Russian, and then it's probably just nonsense because I just randomly picked some Cyrillic characters, okay? So what we've done there is we've overloaded our short-term memory, and we can't really do much with it because nothing there is familiar. We've got nothing to contact it, connect it to. Right, Ted? Yeah, so all we can say is that that's 3 sets of characters, and they may well be words, who knows? So now we can look at that and we can say, okay, I probably can remember more of that. And if you might be surprised that if I ask you later, you can probably remember those letters better than you think. And we'll get to that in a minute. But why is this easier to remember? Well, we have some association with something we already know. So we recognize the symbols because those symbols have been stored in our long-term memory. Okay, so hold that thought. We're going to try this one more time. Ready? Now, I didn't even have to have that up for nearly as long as the other things that I did. And I bet everyone is able to remember exactly what was on that slide. Why is that? Well, we can associate those letters and those combinations of letters with something in our long-term memory. And the combining of things together is called chunking. Okay, that's grouping things together in familiar patterns. Okay, so back to our model. We can increase the effectiveness of our short-term memory by chunking things in a way that associates them easily with something that's already in our long-term memory. So what are some ways that we can chunk the code that we read so that we can understand it more quickly, all right? So I've already given you some simple tools. One simple tool, which is the chunking thing. Real quick, I wanted to talk about when we read some code, it goes through a filter, all right? And that represents basically whatever personal filter you may put on something, how you're feeling, your health, the lighting, your past experiences, and that sort of thing. So before it gets to your short-term memory, it passes through something called sensory memory. And you can think of that as sort of an I/O bus. So when you see something quickly, like we did earlier, the sort of random letters, you're able to remember those because you have a sort of mental picture of it, and it's stored in a special short-term memory called iconic memory. I can't read my own slide. From here, you can make very quick associations with long-term memory. So when I said that you can probably remember that, that's what I'm talking about, this iconic memory. So how can we use this as a tool to facilitate our short-term memory? Well, if you're an experienced developer, what's the first thing you do when you're looking at unfamiliar code? You're gonna probably glance at the shape of the code. It'll give you some idea of the structure and the design. You're going to see, okay, this is a case statement, so we've broken it up. We've got this if statement, this is indented. We're going to basically, the shape of it is going to give us a good idea of what's going on real quickly. Now, this little thing over here is it's a plugin to IntelliJ. It's called CodeGlance Pro. And it's a plugin that I use. It helps me dig through new code. It basically displays a mini map on the side, on the right column, to help you get an overview of the code, so you can see, okay, this looks like it's a bunch of if statements and case statements here, something like that. So you can very quickly see the shape of the code and have an understanding of what it looks like. Okay, for Eclipse and VS Code, it's a configuration setting, so you don't have to do a plugin for IntelliJ. You use the plugin. Okay, so back to our brain model. We can increase the effectiveness of our short-term memory by chunking And what are some of the ways we can chunk the code that we read so we can understand it more quickly? All right, well, we've got this, this sort of memory thing, but what's another thing we can use is design patterns. They're an excellent way to attach a large set of information to a single idea or a word. So, this is the publisher subscriber pattern, or it's also known as observer design pattern. If you know how to implement this well enough, then you're going to be able to recognize it in code that you see. So design patterns are a great way to communicate complex ideas really quickly, and it's a useful skill for refactoring your code to make it more readable. Another thing, this came up in our discussion here, comments can be really helpful. Now, studies show that people who have less experience in software development depend more on comments than people who are more experienced. Why would that be? Well, probably because those of us who have a little more experience have learned that these comments can expire, and when people update the code, they don't necessarily update the comments, so they can often be outdated. We have comments that, like here, they explain why something does what it does, or we can have section comments like this that set off a section of code and describe what it does. I generally recommend that people take something like this and turn it into an appropriately named method. But comments like this can be helpful in helping you when you're refactoring code to clean it up and break it up into smaller bits. So these sorts of things are called beacons. So the comments that that break things up, or well-chosen method names, they're called beacons because they help the reader find their way through the code, similar to how a lighthouse beacon helps the sailors find their way on the sea. There are different kinds of beacons. A simple beacon would represent a single concept or variable name. Compound beacons represent familiar combinations, groups of elements. Why does this matter? Well, because when you write your code, you should leave beacons in your code to make it easier to write. Okay, make sure that you choose good names for your variables, for your methods. Make sure that you have comments that are helpful in guiding a person to understand how the code works. Okay, so with that in mind, how do we use what we know to address the different kinds of confusion that we can run into? All right, so our first problem was lack of knowledge. How do we overcome that? Well, we learn, we research, we figure out, what is this language? We learn the syntax of the language, add that syntax to our long-term memory, so that later we're able to understand this next time we see it in this code or something similar, right? If we're unfamiliar with a particular type of syntax, then become familiar with it. We can learn about it, practice it, study it, learn about it. Take some classes or read some books, or just figure it out, get comfortable with it. If you've got the lack of processing power, how do you read that kind of code more quickly? In a minute or three, we're going to discuss how we can use sort of an external brain extension, but the kind of things that we would do that, you print it out, you step through it, keep track of the variable values and how those change in the calculations. You might use a debugger to facilitate that. Talk about that in a minute, okay? So we'll do a quick exercise, all right? So this is to practice noticing beacons in code. I'm going to show you a small snippet of code. So look over it for a couple of minutes and make a note of the beacons that you see and why you consider them to be beacons. All right. Is this big enough for you to read? you have trouble, let me know. I can size it up. Okay, so if you look at it, okay, so we've got this override tag here, which tells me that this is overriding a function. So that tells me something. This is a I'm extending an existing object. We have our curly braces breaking up the code with the indentation, so that makes things beacons. We have method names, which seem to be meaningful if you know what a menu inflator is. You've got comments that explain how this code, why this code does what it's doing. And we have constants here that are hiding the magic numbers so that we don't have to try and figure out what that means. So fab dismisses a 1. And we have other functions and that sort of thing. So okay, so these are our beacons that we can see in code that we read, that we can see what makes it easier to understand. All right, now, okay, so our first 2 ways of getting confused are remedied by learning stuff and remembering it. How do we make remembering stuff easy? And do I need to remember all this stuff? I mean, what's wrong with Google? Isn't Google supposed to keep us from having to remember everything because it's right there close at hand? Okay, there's a number of good reasons why you would want to remember stuff and just have that information in your head ready to use. First, the more you know, the more stuff you have in your long-term memory, the faster it is to learn new stuff and be able to associate that with stuff in your long-term memory. Also, when you stop to Google something, you're breaking the flow that you have as you're reading something or as you're writing something. And then when you get distracted, on average, it takes you at least 15 minutes to get back to where you were. And that's assuming that you didn't bring up Twitter and start running down your Twitter list of a million things to read forever. Okay, so the way our brains remember things is usually through repetition. There's also, noteworthy events like crises or surprises. Those can be memorable, but we're not addressing that right now. Most of our life isn't that noteworthy or surprising. We need to spread out the learning and try not to cram everything. Of course, that's the opposite of what we do in college and in school, but we learn a lot of stuff once we get out of school. So what we want to do is when we learn something, basically it has a rate of decay. So, we learn something the day 1, it's going to decay quickly. By the end of the day, we'll remember less than half of what we learned. But if we go back and repeat that learning a couple of days later, then we will remember more of it for longer. And if we go back a few days later and repeat that learning again, where we remember it even more. So there's this, if we can take advantage of this decay in our memory and review the material daily, or there's optimal times that we can have it brought back to our memory, then we can remember things almost indefinitely. Okay, and this is called spaced repetition. Okay, so there are these flashcard apps that make it easier for you to practice this spaced repetition. People use them to learn new languages, but you can use them to learn just about anything. And since lots of developers are trying to learn lots of things, chances are good the thing you want to learn is already available in an existing flashcard deck. Okay, so as you practice the exercise we went through earlier, the just recognizing the beacons, you're going to notice things that you don't understand but should understand, and this is a great way to determine what cards you might want to add to your deck. So let me bring up an example of this. We've got this Anki deck. I know it's kind of small here, but here is a JavaScript deck that that someone wrote that's got dozens of questions, and all you do is you say, okay, I want to study JavaScript when console logging multiple values. What can you wrap the call in to log the names of the variables for clearer results? Let's see, I could wrap that in, I don't know, a class. No, you wrap it in curly brackets. I'm way overthinking this, and I clearly haven't worked through my JavaScript. So, but you notice what I did is I guessed at what it was. So this is an important memory tip. We remember things better by practicing remembering. So you want to read the prompt on the flashcard at the top, and then try to remember the answer before you read the other side, okay? Because by doing that, you're going to strengthen that muscle, okay? So there's two things we want to strengthen with regards to our memory. You've got storage strength and retrieval strength. For storage strength, you just need to do the repetition thing a few times, and it will generally be in your memory. There's probably, we can all think of times when you forgot your phone number or your wife's phone number or something like that. The information's in your brain. You just can't recall what was in your brain. So what you really need to work on is your retrieval strength. And you develop your retrieval strength by practicing it. So when you're going through and trying to make sure that you remember something, you can basically do a memory workout by practicing remembering. Just try to remember what it was before you go and hit Google, or before you go and you flip that card. Try and remember it. That will strengthen your recall. Okay, so I mean, I store things at home for quick retrieval, okay? Which means it's all out on the tables and in piles. And my wife hates the clutter, all right? My wife stores things for the removal of clutter because she just doesn't want to see it. So she'll take it and cram it in a drawer somewhere. She doesn't care if she never sees it again until she does. And then, of course, she calls me because I'm very skilled at retrieving things from places where they're hidden. All right, now, we don't necessarily remember things exactly as they were. Our memories are oftentimes colored by our experiences, personal, cultural filters, whatever details of what we're trying to remember can be altered or forgotten. It's like, was it Longhorn or Shorthorn? I don't remember. So there's an idea called elaboration, and that is the concept of thinking about what you want to remember. Okay, so you relate an existing memory, you intentionally relate an existing memory to make the new memory fit into the existing long-term memory. Okay, so let's consider a new concept you want to learn. Say, for instance, you want to understand new pattern matching functionality in Java, or comprehensions in Python, okay? And comprehensions are a way to build up an array, okay? You want to make sure you remember it correctly, as syntax errors can slow you down. So I'm going to work through an exercise real quick. to help you remember a new programming concept, all right? So first, you look at this concept and you think, what does this new concept make me think of? And what related concepts does this make me think of? So what are all the similarities to other concepts? From there, I can then, for each of the related concepts I can think of, I can say, why does this new concept make me think of this concept I already know? Does it share syntax? Is it used in a similar context? Is this new concept an alternative to one that I already know, so I could go either way? And then, what are some alternatives? What are other ways that I already know to write code to achieve this same goal? So I can write a loop, you know, for each number in this list. I'm going to multiply it by, or I'm going to square it, and then I'm going to store it in the array. Okay, so do other programming languages have a concept like this? Maybe I can write down examples from other languages that do similar operations. And how do they differ from how this syntax works? Okay, and finally, does this concept fit a certain paradigm, domain, library, framework? What is the general concept of this concept? What's the general milieu, whatever it is? How do you come up with a better term? Anyway, so is this in a certain area that, or grouping that I could associate it with? Okay, so we've learned how to improve our ability to read code that we don't understand. What about code that's just too complex to figure out? Okay, so remember, we have short-term memory, and this helps us to remember information by sending it to the working memory and associating it with something in long-term memory. So the working memory is used for processing the little bit of information that we're able to cram into our short-term memory. So our working memory is able to process 2 to 6 things at a time, which is, you know, as much or less than the short-term memory, right? So if we try and handle more than 2 to 6 things, we get what's called cognitive overload, right? So there are 3 types of cognitive load. There's your intrinsic load, which is essentially how complex the problem is all in its nature. There are extraneous load, and that's what other distractions are there that make the problem harder to understand. And then there's the germane load, which is the work you have to do to take that idea and store the thought into long-term memory. Okay, so you look at it, if you're in, for example, you're calculating a least squares algorithm. The intrinsic load is the basic formula to draw the line that we want. The extraneous load would be the intermediate variables that we use, or the methods that we call, or the special syntax that we use to function, to figure out how we get to the solution. And then the germane load is a way to find and filter down the essential parts and associate them with a long-term memory so that they're stored and can be recalled properly. All right, so let's do a quick exercise of reading some unfamiliar code. We've got this code here. Notice when you feel the need to make notes or to take smaller steps as you're reading through this code. What kind of cognitive load are you experiencing? Is it an intrinsic load? Just, you know, the problem itself is complex? Or is it extraneous? Is there some other thing that's distracting you and making it harder to understand. Right, so Marty says sometimes he'll insert his own comments as he figures things out. And that's an excellent way to do things. I do that myself. Help out that next guy who is likely me a couple years down the road. So we can look at this, the intrinsic complexity. So you see we've got two nested loops inside of a main loop that are using different counters. Actually, this is reusing the same counter, which is very well named. So there's an extraneous load of a variable named u, a variable named v. What the heck is a u or a v? It's probably just a counter, but you know, u, is that meaningful? Maybe we should turn this into a method call, even though I am just dereferencing script of a subscript, which is hairy. If I could break these even simple things like this up into small methods, I could make that easier to read. And it looks like a tree traversal algorithm. It is a, what do you call it? I should have written it down. It's finding the traversal of a tree, the optimal traversal of a tree. So yes, you're right. Minimal spanning tree. Thank you, MST. Thank you. Y'all are smart. Okay. So how do we reduce our cognitive load? We mentioned one idea already. You refactor it by, we can add comments. We can refactor it, break it up into smaller pieces, break out certain sections and turn it into subroutines. We can remove duplication, like, back here we had V used here and V used here, which may not matter, but it's still confusing because we're reusing a counter in the same code. And does it have meaning when we get to the bottom? I don't know. But if we remove that duplication, we can just basically go through and simplify things. Now, when you're doing this this kind of refactoring, you don't necessarily have to refactor it to create a, to make it releasable. I will do what I call a temporary refactoring, or Felina calls it cognitive refactoring, but I just call it a temporary refactoring. I go through and I break it up into smaller pieces that make more sense, so that I don't have to worry about breaking tests or anything. I'm just trying to understand the general flow, and then I can go and just revert it back to how it was before. A lot of times when we're doing this, also we'll want to do reverse refactoring, where we'll take methods and we'll want to inline them just so that we can read the code from top to bottom, even though breaking it up makes it easier to maintain, but reading it from top to bottom makes it easier to read. So your mileage may vary. So another thing we can do, it's a type of refactoring. You can replace advanced language constructs with simpler ones that you understand better. If you don't have lambdas mastered yet, or anonymous functions, or sometimes even ternary operators, people can get confused by them. So you can expand it out into a full if statement and simplify it. So just make the code easier to read. Like I said, sometimes it's just easier to read it from top to bottom without having to go through and dig out the methods. You stick the method name as a comment. Of course, like I said, this is readability is in the eye of the beholder. Excuse me. Yeah, you can always roll back to how it was when you started. Now, if you do find yourself expanding out unfamiliar language constructs, this is a good signal that you need to spend some time learning them so you can create some flashcards. If you think about it, a 10x developer works on code faster because he has all the knowledge right there at instant recall. Usually a 10x developer is the guy who wrote the code, or the gal. You know, using the skills that we've discussed, you can grow your skill base surprisingly quickly. And whereas you may not become a 10x developer right away, you can become a 2, 3, 4, 5x developer by having all sorts of things at instant recall. Being able to do that quickly makes you much more effective in what you're doing. Okay, so there are helpful tools that we can use to, you know, take that part of our brain that gets overloaded and externalize it. They can be online, or you can use a paper and pencil. Things that we can do: create a dependency graph or a state table, or combine dependency graphs and state tables. What the heck am I talking about? A dependency graph. That's where basically you take the code and you highlight sections of it. You can draw arrows, you know, see how this function is called in 3 different places here. And we pass in a value variable, and then we actually use this value here, and that's different from the S value or the new value. So we should probably keep those separated. And this is what I'm showing here. You can do it using a highlighter and pen and pencil, but this is a tool that Felina Hermans has created. It's on her site, Code Reading Clubs, codereading.clubs, and it's a tool that basically you point it at a piece of code in GitHub, and then it will let you go in there and start coloring it and marking it up. Personally, I prefer to just print the darn thing out and scribble on it. I'm an old guy. Now, if you find yourself, you know, looking at all the different variables and you want to keep track of it, maybe this presentation is a subset of the task of a new developer to become familiar with a large code base at a new job. Yeah, absolutely. Yeah, these skills that we use to make our brain work better certainly can help a new developer, but they can also help us old guys who've been developing for a while to pick up the new technologies, which are, as you may have noticed, changing at light speed. So this would be a state table. You see, I like to scribble things by hand, but you'll take your variables and say, you know, each variable has a value. So initially, this is the value that it has. In the first loop through, it's going to be changed to this value, and then the next loop through, it's going to be changed to this value. So these are ways that you can keep track of how variables change. Again, you can use your debugger to make this easier, or to help you do that. There are tools out there that will let you walk backwards in your code tracing as well as forwards. And but you know, a pen and a piece of paper will get you there too. You can, like I said, combine dependency graphs and state tables to increase the depth of your understanding of how systems work, how unfamiliar code works. Okay, so some other tools you can use. You got your IDE. You know, there's the syntax coloring in your IDE. Identify loop invariants. Should they be in the comments? So an invariant, yeah, I guess it would probably be a good idea. Well, you'll at least want to comment it when you're walking through and making note of the things that are invariant. A comment to that effect would probably be helpful for helping you to understand it as you're working through it. That's for sure. But yeah, that's a good point. Okay, so basically you can, syntax coloring has been really helpful in IDEs for those of us who, from the old days when everything was on a green screen. Yeah, it comes in very handy to help you recognize, where are the variables, and this is the comments are hidden here. You've got the method calls, you've got your reserved words, you've got the functions that you call. The IDE makes it much easier to understand this. Okay, so this constants are highlighted. And so, yeah, I like syntax highlighting. Also, there's the your plugins that you use, and you've got your you can look at your tree structure of how things are laid out, so you can see the relationships between your functions and how they relate to one another. So yeah, your IDE has a whole bunch of helpful things that it can use to help you understand code more quickly. I'm a big fan of printing it out and scribbling on it. So having colored pencils and pens and highlighters can facilitate that. Your debugger, you can use your debugger to help you understand code that is complex, and how the general flow of an application is. Conditional breakpoints, if you learn how to use conditional breakpoints in a debugger, that's cool too. So you set a breakpoint here, and you can set a condition, say, if subreddit contains whatever. So you can set say, I want this to be suspended when this value is there. So that can be really helpful to help you dig through your code more quickly. Your profiler can help you as and your debugger, I guess, in seeing the call stacks that you have as you're working through code. Of course, log files have been a tried and true means for understanding how the program flows and how it works. If you want to dig more deeply into specifically how to use your debugger and your profiler more effectively, there's a new book that came out just a couple months ago called Troubleshooting Java. I mention it here because, frankly, yeah, I agree, Marty, those were the days. The reason we find ourselves reading unfamiliar code is generally to find a problem and fix it. And this book is a really helpful resource in helping you to use the tools available, especially for Java, to help you not take as much time to track down the source of the problem. You want to get there more quickly. I enjoy tinkering around the house, but it'll take me half a day to, let's say, hang a door or paint a fence or something like that. If I hire somebody who does it professionally, they get the job done in 30 minutes. They have to. I mean, they have to get to the next job as soon as possible. They can't waste time tinkering around, running to Home Depot 5 times for that one thing that you forgot. Oh, and you forgot that other thing and that other thing. So this book, along with the skills that we've discussed earlier, will help make you a better professional by minimizing the time that you waste trying to understand the code and ultimately finding and fixing the problems that you have in that code. Okay, so So in summary, basically, there are three kinds of confusion. There's a lack of knowledge, a lack of information, and a lack of processing power. And then there's the three ways to overcome that confusion. You can add more information to your long-term memory by learning about it, studying it, practicing it, and using these the flashcards. You can also increase the strength of your retrieval capabilities. Once you have stuff in memory, you can practice remembering things so you can increase the strength of your retrieval. I have much less trouble remembering my wife's phone number than I do my daughter's phone number. I call my wife much more often. That's just the way it is, because I'm practicing the retrieval of that memory. And finally, we can use whatever tools are available to us to reduce the cognitive load as we're dealing with processing power issues and problems. Okay, so I would recommend, well, I'll challenge you to start a code reading club among your coding friends or some of the people that you work with, or you can join a code reading club online. Felina Hermans has a link. Well, this is a link to a site that she has where she has the tools and links to other code reading clubs. There's Python club if you want to learn how to do Python programming. Also, there is a group called Legacy Code Rocks, and they have a site called Awesome Legacy Code. Let me bring that up. It's really cool. And they call it a curated list of legacy systems with publicly available source code. You've got the Apollo 11 guidance computer code. You can see the code that they had to cram into that tiny little bit of core memory that they used for the Apollo 11 astronaut mission. See the magic that they were able to do. You can see the Microsoft GW Basic Interpreter, MS-DOS. We'll see how Wolfenstein 3D works, or Doom. You can also, frankly, you can look at Java. So say, for instance, you want to see how string works. You can go and control click on that. I'm sorry, control click on that. There you go. And I can look at the source code for the string object, and I can see all the amazing things that it does for how it works. And I can learn things about string that I never knew existed. So read the JDK so you can have a better understanding of how it works and how the people who designed the language intended for it to be used. There are open source projects that are always looking for people to help. You can go and just look through an open source project and see the code that other people wrote, and you can learn a lot about how other smart people have done things, people who love to code, and you can look at ways that people have done really dumb things too. You'd be surprised at the things that you can learn out there in the wild, wild world of amazing code. So, so I challenge you to go out there and start reading code for fun. I know it's not fun usually. It's because it's really hard, but the more you practice at something, the easier it becomes, and the more fun it becomes. We tend to enjoy doing things when we've developed competency in it. You may remember when you first learned object-oriented programming. I know for me, it took me weeks to get my head wrapped around the various concepts in object-oriented programming, because I had been programming in structured programming for so many years, and object-oriented was just a whole new way of thinking about a problem. But now I enjoy doing object-oriented programming because I'm very familiar with it and confident in it. So, like I said before, you can't write readable code unless you can recognize poor code. So to that end, I've written a short ebook that lists most common code smells and how to refactor them. If you get it, you can also get my my daily suggestions on refactoring and writing clean code. I will go ahead and put it in the chat here, the link to that. So, but let's see here. But that's effectively what I have. So go read some code. And if you have any questions, concerns, you can ask me here, or you can always drop me a line. This is how you can get a hold of me, through email and Twitter. And I hope you found this helpful. Let's see, how do you project task completion time in this scenario? Well, the scenario of learning something new, that really depends on how much you already have crammed in your long-term memory and how skillful you are at adding things to that long-term memory. So, you know, how long does it take to master this? Well, I've been programming for about going on 40 years, and I'm getting okay at it. So this is a lifetime exercise that I don't know that there are many people who have it mastered, but we're always learning more. So I guess I will stop sharing. Do we, does anybody have any questions or comments? Any war stories you want to share about ugly code that you've had to dig through?
Well, if there's no more questions here for Scott, then I guess we can go ahead and end this and we'll move on to our raffle. But anyway, thanks for a great presentation. Normally, if we were meeting in person, we'd have a big round of applause.
Well, I can feel the love coming in. It's okay.
All right. All right. Well, thank you very much, Scott.
Thank you, guys. I appreciate it. I really enjoyed it, and I wish you all the best.